Welcome back to Easily Explained, where today we will be talking about the recursive formula of an arithmetic sequence. So let's get started. First, what exactly is an arithmetic sequence? An arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant, and this constant is called the common difference. Let's look at an example of an arithmetic sequence. We have 15, 20, 25, 30, 35. So in this sequence, the difference between any two terms is always 5. It's always constant. It's always the same. So therefore, 5 is the common difference because from 15 to 20, we added 5. 20 to 25, we added 5. 25 to 30, we added 5. And 30 to 35, we added 5. So this is how the sequence will continue to go. Alright, so now that we reviewed what an arithmetic sequence is, let's go over the recursive formula. In the past, we went over the explicit formula where we use the common difference and the initial value to find the nth term. Now we're going to be going over the recursive formula. The recursive formula is a formula that uses the preceding term to find the next term in the sequence. So sometimes the explicit formula can be more useful because in the explicit formula, even if you're just given the third term, you are able to find the 100th term, for example. Whereas with the recursive formula, to find the 100th term, you would need the 99th term. So you need the term before it. And so it would be harder to find the 100th term if your sequence has only 3 terms, because you would have to find the 4th term, then the 5th term, then the 6th term. Whereas if you just use the explicit formula, you could automatically go from 3 to 100. The recursive formula is a sub n, that's our nth term, is equal to a sub n minus 1, that's our previous term, because remember, n is the term number, so then the nth term is equal to a sub n minus 1 equals the previous term. So the nth term is equal to the previous term plus the common difference. So this is basically just a fancy way of saying that 15 plus 5, the common difference, is equal to the next term, 20. So if you just continued to write the rest of the sequence without using any formula, you're basically using the recursive formula without knowing that it's the recursive formula. Now let's use the recursive formula in different sequences to find the next term. We have the sequence 8, 12, 16, 20, 24, and the sequence will go on forever in this way. The first thing with any arithmetic sequence, whether you're using the recursive or the explicit formula, one thing common is that you have to find the common difference. It is true that with the recursive formula, you don't need to separately identify the first term in the sequence, but you still need to identify the common difference, which in this case is 4. So D is 4. Now that we have identified the common difference, we just need to use this recursive formula to find a sub 6. We want to find the next term because we have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So now we want to find the next term in the sequence. Alright, so the 6th term is equal to a sub 6 minus 1 plus d. So the 6th term is equal to the 5th term plus d. The fifth term, we want to substitute it in now, 24, and then substitute our d as 4. A sub 6 is 24 plus 4, which is 28. So our next term would be 28. Let's do one more example of using the recursive formula. Now our sequence is 15, 17, 19, 21, 23, 25. So let's identify our common difference. Plus 2, plus 2, plus 2, plus 2, plus 2. So d is equal to 2 in this case. Now we want to find the seventh term of the sequence, which is going to be the previous term, so a sub 7 minus 1, plus the common difference. So we're going to find the sixth term plus the common difference. We can plug in the sixth term, which is given to be 25, plus 2. So the seventh term is just 27. Now it's time for your practice. Use the recursive formula to find the indicated term number of the arithmetic sequences below. For each arithmetic sequence, you're going to find the fifth term and the sixth term. Also remember that the recursive formula relies on the previous term, so make sure you first find the fifth term with the fourth term, and then find the sixth term with the fifth term. Pause the video now and get started on the practice. Alright, let's start with number 1. So if we are to find the common difference, we can see that each preceding term, you add 6 to it, and that gets you to your next term. Therefore, we know that d is equal to 6. So now from our common difference, we can plug it in, say that the fifth term is equal to the fourth term plus the common difference. So a sub 5, the fifth term, is equal to the fourth term, 30 plus 6, therefore it is 36. And in the same way, now we're going to use the fifth term, 36, plus 6 again to get 42. So we're going to do the same thing for number 2. Since it's plus 7 plus 7 plus 7, our d is equal to 7. So now we're going to do a sub 5 is equal to the fourth term plus d. And the fourth term is 28. We're going to do 28 plus 7 to get 35. And now we're going to use that for the sixth term, because that is the fifth term plus the common difference. So the sixth term is equal to 42. In number 3, d is equal to 3 because the common difference is 3. I did the exact same thing to get the fifth term as 14 and the sixth term as 17. So as you can see, up until the third step, it's always the same. But the third step is where you can plug in the numbers to each specific sequence and the common difference to each specific sequence, and that gets you your new term. But if we just look at all of the fifth term answers, so the first part of each question up until step 3, they're all the same. And same if we just look at all of the ones for the sixth term, they're all the same, except when you have to plug it in to each individual sequence. Congratulations! You are now an expert at the recursive formula of an arithmetic sequence. If this video helped, please like, subscribe, and share with your friends. And we'll see you guys next time. Bye!